Now, in U5A2, what I'm going to do is take all the information and I'm going to spin it back to you in a different way. Instead of going with Ohm's laws and Kirchhoff's laws, I'm just going to show you what you need to do the analysis. So I'm not really going to name the laws here. I'm just going to show you the rules. So what I have here is I have a series circuit, and here are my rules as I'm going through this circuit. My rules is I total, which is amperage, equals I1, I've got this wrong. I1 equals I2. I total equals I1 equals I2. Guys, what that means is if this is a 2 amp circuit, it means I have 2 amps here, 2 amps here, 2 amps here. No matter where I put my ammeter in the circuit, I'm going to measure 2 amps. So when you're in series, your amps are your amps are your amps. So if I put an A in here, like an ammeter in here, an ammeter in here, or an ammeter in here, I'm always going to get 2 amps. Now, what happens to volts when we're in one of these circuits? V1 plus V2 has to add up to V total. So let's say that V1, okay, let's say first of all that this was a 2-volt battery and this is a 2-volt battery. They're actually cells, a 2-volt cell and a 2-volt cell. 2 and 2 is 4 volts altogether in the circuit. Let's say that 1 volt gets used up at this first load. How much would get used up at the second load? Well, at the second load it would be 3 volts, because what has to happen is the total voltage in the system, which is found right here, it's 4 volts, has to get used up in the circuit. So it would be 1 volt there and 3 volts there. Now I arbitrarily made that 1 volt, but if we know that 1 voltage, we'll know this voltage over here because it has to add up to 4. Now, we can also use formulas to try and figure things out. So if we know 2 of our 3 statistics, or 2 of our 3 values, I should say, at any one of these spots, we can figure out the third. If we need to find voltage, we'll use I times R, amperage times resistance. If we need to know amperage, it's voltage over resistance. And if we need to know resistance, it's voltage over amperage. So let's take a look at resistance 1. So we're taking the resistance right there. We're going to use our formula to find this one. We know that resistance is equal to voltage over amperage. We said our voltage was 1 and our amperage was 2. So that's 1/2 or 0.5 ohms. If we took a look here, once again, we said no matter where we go, our amperage is the same. Our resistance is equal to, or our voltage is equal to 3, and our amperage is equal to 2. That's 1.5. If we want our total resistance in the whole system, it's going to be R1 plus R2. So it's going to be 0.5 and 1.5. That's going to be 2 ohms of resistance in the system. So our R total is going to be 2 ohms. Folks, they use Kirchhoff's rules. They develop things in the unit. I'm showing you how to take a series circuit and a parallel circuit and apply the rules. What you're going to notice is the rules are going to change as we go through here. So when we go from series to parallel, we got a new set of rules. So when we do amperage in parallel circuits, the amperage total is equal to I1 plus I2. Folks, I want you to remember the content will develop how these rules came about. I'm showing you how to use them, and this is the stuff you're going to get on the test. So let's say that we have a 4 amp system. That means that we would have 2 amps and 2 amps because the amperages have to split, okay? The other thing we could do is we could be given the voltages, and we can say that the voltages are equal to the total voltage. So if we say this is a 4 volt system, this will be 4 volts, and this will be 4 volts. Now, I'm going to get rid of the amps and pretend I never said this. Let's do a different thing here. Let's use our calculations. Let's say we know we've got a 4 volt system and a 20 ohm resistor system and a 4 volt system and a 10 ohm resistor. We can use the formula I equals V over R. So that would be 4 over 20, which would be 0.2 amps. Or for this one, we could use I equals V over R, which is 4 over 10, which is a 0.4 amp system. So this would be 0.4 amps. Remember, sometimes you can do a calculation using these formulas, or you'll have to, and sometimes they will give you values as you're going through. So what I'm showing you right now is your rules for series, your rules for parallel, and the formulas you can do. Now here's the trickiest thing you have to do, and I do it a little different than the content. So use my method or use the contents method for figuring out resistance in parallel. That's the hardest thing to do. 1 over resistance total equals 1 over R1 plus 1 over R2. Then what I do is I put those values in. So it's 1 divided by 20. So 1 divided by 20 is 0.05, plus for R2, it is 1 divided by 10 is 0.1. So 1 over RT is equal to 0.15, which is the same as 0.15 over 1. So to solve for RT, all I do is flip both sides. Math teachers would kill me for doing this. RT is equal to 1 over 0.15. So now all you do is you divide 1 by 0.15, and that's equal to about 6.7 ohms total. So that's the toughest calculation you have to do right there, is finding resistance total in parallel. Folks, I have students tell me all the time, the best thing about online learning is if you didn't pick something up, watch the video again. These are the rules that you need for the content in U5A2. I suggest you look at the content. It goes into a little more detail, but I show you the formulas you need, and I show you the rules that you need for figuring out amps, volts, and resistance in series and in parallel. What I don't do is name Ohm's and Kirchhoff's rules as I go through this. Okay, that looks like that's the end of U5A2.